Okay, today we're going to be talking about some counting techniques in probability. Okay, and hopefully by the end of this video you will have a better understanding of how to use these techniques. Okay, so looking at the first problem we have, how many ways are there to choose a president, a treasurer, and a secretary out of 5 people and out of 10 people? Okay, so we've got two different formulas here. Okay, the first one's called a combination. When you're using a combination problem, you're saying that there's nothing unique, basically. Unlike this problem, because you have 5 people, and we know that people are unique. So one person is different from another person. Okay, so in a combination, nothing is unique. So the order doesn't really matter. If Bob and Sally and Joe were to all be part of a group, they would all be unique. All right, so depending on their position and depending on who they were, it would matter. Like if Bob was president or if Bob was instead treasurer, those would be two different things. Even though they're both part of the committee, they would be holding different positions. Okay, so this is not a combination. Okay, this is what we call a permutation. Okay, a permutation is when one choice matters over another choice. Even if the same 3 people get chosen for president, treasurer, and secretary, those 3 people could be having different positions, which would be different counting probability. Okay, so we're going to use the permutation one. Okay, and what the N stands for is the total number of objects, and what the R stands for is objects chosen. Okay, so looking at that, let's look at A. It says 5 people, so we want to choose a president, a treasurer, and a secretary out of a group of 5 unique people. So we're going to use this one. Okay, so the total number that we have is 5 people, so we have a 5 factorial, and we'll talk about factorials. If you're a little iffy on that, we'll talk about it in a minute. Divided by, again, n is 5, minus, how many are we choosing? 1, 2, 3. Okay, so 3 factorial. Okay, so that would give us 5 factorial over, what's 5 minus 3? That's 2 factorial. Okay, so how do we solve it when it's at this point? Okay, now you can use your calculator, but this is one time where your calculator probably is not going to be as helpful as just doing it by hand. Here's what factorial means. 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. Okay, so notice that these two things cancel because they're on top and bottom. Okay, so we're left with 5 times 4 times 3, which is 60. So the quick way to do this is you get more practice with this. You'll see the 5 up here, factorial, you'll see the 2 factorial, and you'll do this part. You may do this part in your head and just say, okay, well, if I know there's a 2 factorial down here and there's a 5 factorial up here, you may cancel these two terms in your head and know that there's just 5, 4, and 3 left on top. Okay, now let's take a look at B. The only difference here is we have 10 people. Okay, so our total number is 10, so 10 factorial over 10 minus 3 factorial. Okay, so that is 10 factorial over 7 factorial. Now, if you remember what we just said up here, if you've got a 7 on bottom, a 10 on top, we know that 7 of this 10 factorial is going to go away, and it should just be 10 times 9 times 8. But let's write it out one more time, just so we can make sure and understand this. Okay, there's the numerator. And there's the denominator. Notice all these terms are canceling out, and it leaves 10 times 9 times 8, which gives us 720. Okay, so how many different ways are to choose a president, treasurer, and secretary out of 5 people? 60 ways. How many different ways are there to choose those out of 10 people? 720 ways. Okay, let's move on. This problem, we're given that there are 8 actors in a production. How many ways can the director arrange the cast if every actor plays exactly one part? Okay, so again, this is going to the actors are unique people. Okay, so it matters. The order matters because one person is different from another. So this is going to be another permutation, the one with the p. So this is going to be the NPR, which is n factorial over n minus r factorial. Okay, so for this problem, we are going to have what? Well, we have 8 actors, and we want them to each have one part. So this is going to be 8p8. Okay, 8 actors, 8 parts. They're all unique. So 8 factorial over 8 minus 8 factorial. So that's 8 factorial over 0 factorial. Okay, so this is something we need to talk about. What is 0 factorial? Because we've talked about like what a 5 factorial is. 5 times 4 times 3 times 2 times 1. You could even say that 1 factorial would just be 1 times nothing, just 1. But what is 0 factorial? Well, you have to just rely on the definition of this, so I'm just going to tell you. The definition of 0 factorial is 1. Okay, so this is going to be equal to 1. So 0 factorial is equal to 1, and also 1 factorial is equal to 1. Those two things are always going to be true about factorials. So with a 1 on bottom, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1. Okay, and if you multiply that all out, you'll get 40,320. You can multiply it in your calculator. Okay, so there's 40,320 different ways of arranging the cast if there are 8 actors and they each get one part. Okay, next problem. How many ways are there to choose 5 letters from the English alphabet if no letters can be repeated? Okay, so as we know, the English language or the English alphabet, every letter is unique. Okay, 26 unique letters. So this is another permutation. Okay, NPR equals n factorial over n minus r factorial. Okay, so we're going to have total numbers, the letters of the alphabet. There are 26 of them. 26p, and we're trying to choose 5. So we're going to get 26 factorial over 26 minus 5 factorial. Okay, that's 26 factorial over 21 factorial. Okay, and we can use, this is a lot to write out, so we're going to use that little trick. Remember, 21 of the factorials cancel, okay, leaving on top the 26, 25, 24, 23, and 22. Everything else is going to cancel, right? The 21 times 20 times 19 and so on cancels with that same terms on top. So if you multiply those together, you're going to get a really big number. You're going to need your calculator for this one. 7,893,600. So there are that many ways, almost 8 million ways of randomly choosing 5 letters if no letters can be repeated in the English language. Okay. Moving on. Find the number of arrangements of letters in the following words. Okay, so this is going to be a little different because if you notice, these words have repeating letters. Okay, so if I look at this and I say, okay, well, what if I started with an A? Was there any difference between starting with this A and with this A? I mean, they're both going to be included because you got to include all the letters, but there's no difference between using this A or this A or this A, or no difference between using this N and this N. Okay, so we gotta slightly change the formula. So when you've got repeating letters like this, so there are some unique things and there are some things that are not. Like the B is unique. There's no other B's. Okay, but the A and the N is not. They are not unique. Here's how you do that. You're going to do n factorial divided by r1 factorial. That's the number of repeating things. Like if we were doing A as R1, there would be 3 of them. So it would be 3 factorial here because there's 3 A's. R2 factorial, we could say that R2 was N. So there's 2 of those, so that would be a 2 factorial. And R3 factorial, and you just keep going until you run out of letters. Okay? N factorial, or the N is the total number of letters. Okay, so 1, 2, 3, 4, 5, 6. So in letter A, we've got 6 factorial on top. And then R1 we said was A, so there's 3 of those, so 3 factorial. R2 we said was N, so 2 factorial. And then R3 we said was B, so 1 factorial. Let's clean that up. So 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1 times 1. Okay, so 3 and a 3, 2 and a 2. 1 cancels, but the 1s don't really matter anyways. There's nothing directly for the 2 to cancel with on top except for the 6 or the 4. They're not going to completely cancel, but they will reduce. So 2 will go away, and if I divide 2 into 4, it becomes a 2. So this becomes 6 times 5 times 2, which becomes 60. Okay. Let's look at the next one, statistics. Statistics. So how many letters do we have total in statistics? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the top is going to be 10 factorial. And then let's start with S. How many S's do we have? 1, 2, 3. So 3 factorial. How many T's do we have? 1, 2, 3. So another 3 factorial. How many A's? Just the 1. So 1 factorial. Already did T. How about I's? That's 2 factorial. And I think the last one is going to be the C, which is 1 factorial. Okay, so 10 times 9 times 8 times 7 times 1, and then on bottom we get 3 times 2 times 1 times 3 times 2 times 1 times 1 times 2 times 1 times 1. Now you don't have to write all those 1s if you don't want to. I mean, technically they're there, but multiplying by 1 does nothing. It does nothing to change anything, so you don't have to put them there. Okay, the 3 and the 3, the 2 and the 2. I'm just going to cancel out all the 1s because they don't really matter. Let's see, these two give you a 6 if you put them together, right? So I can cancel those two with a 6 on top. And is that it? No, we got a 2 here. Okay, so 2 can go into 4 twice, so I'll change that to a 2 there. Okay, so that gives us 10 times 9 times 8 times 7 times 5 times 2, which is 50,400. Okay, so that's the number of arrangements you can make using these letters. Okay. Next problem. There are 35 books in a free book bin. You are allowed to choose 3 books. How many possible combinations are there? Okay, so in this one, do we know that these books are unique or not? Are these books unique, or could they all be the same book? It doesn't say 35 different books, right? It just says 35 books, so they could all be the same book. They could all be like Call of the Wild or 20,000 Leagues Under the Sea by Jules Verne. They could all be the same. So if we don't know if they're the same or not, then we need to use a combination. Okay, and that was that other formula, NCR. Some people say N choose R. Okay, so that is N factorial over R factorial times N minus R factorial. The only difference is this right here. Okay, that's the only difference, is that R factorial being on bottom. Okay, so the N still counts as 35. That's a total number. The R is still 3. That's what you're trying to choose. So in this particular problem, we have 35 factorial divided by 3 factorial, and then 35 minus 3 factorial. Okay, so 35 factorial divided by 3 factorial, and that's 32 factorial. Okay, so we're going to have to use that trick again because I don't want to write out all 35 numbers here for the factorial, and our calculator will overflow if we have to try to put that in there. Okay, so we have to use that trick to say, okay, we'll take out the 32, all 32, and what does that leave? That leaves 33, 34, and 35 on top. Okay, and on bottom we get 3 times 2 times 1. Okay, so the 3 can go into 33 11 times. The 2 can go into the 34 17 times. So you get 35 times 17 times 11, which is 6,545. Okay. Now again, the reason we use the combination and not the permutation is because we don't know if there's any difference between any of these books. It did not say 35 unique books. If it said 35 unique books and you can't choose the same book, okay, then we would have used a permutation. But it just said 35 random books, choose any 3, and they can be the same book if there are multiples of them. So that's the reason that we used a combination. Okay, last one. So given a class full of 12 girls and 10 boys, answer the following questions. First, how many ways can a committee of 5 consisting of 3 girls and 2 boys be chosen? Okay, so you've got a little bit of a nuance here in this problem, because you're splitting it up, saying, well, out of the total number of, we've got 12 girls and 10 boys, you want 5 of them, yes, but you want 3 to be girls and 2 to be boys. So we're going to have to do two different combinations and then multiply those answers together. Okay, so for the girls, 3 girls, we're going to do 12 combination 3, okay, or 12 choose 3, some people might say. And for the boys, so let me put these in parentheses because they are going to get multiplied. You're going to do 10. Where'd the 10 come from? Right here, 10 boys, just like the 12 came from 12 girls. Okay, so this, you could even write girls and boys here, just to differentiate. Okay, so 10 choose 2. Okay, so let's see, that will give us, you remember we're using the one that says n factorial times r factorial times n minus r factorial. Okay, so we've got 12 factorial divided by 3 factorial times 12 minus 3 factorial times 10 factorial over 2 factorial times 10 minus 2 factorial. Okay, so that one is going to be 12 factorial over 3 factorial, let me get out of that sun, over 3 factorial times 9 factorial times 10 factorial on top over here, and then we had a 2 factorial on bottom and an 8 factorial on bottom. Okay, so we need to clean this up. That's a lot of factorials, all right? So the 9 would cancel with this and leave 12 times 11 times 10. The 8 would cancel with this and leave 10 times 9. Okay, so that's 12 times 11 times 10 times 10 times 9 divided by 3 times 2 times 1 times 2 times 1, and we don't need the ones. Okay, so let's see, 2 goes into 10 makes it a 5, 2 goes into 10 makes that a 5, 3 goes into 12 makes that a 4, so we get 4 times 11 times 5 times 5 times 9, which is 9,900. Okay. Letter B. What is the probability of the event that a committee of 5 chosen at random from the class consists of 3 girls and 2 boys? Okay, so to do this problem, we're going to use the information that we found in the last problem. So let me write that part down. The top of this, and remember this is a probability, so there's going to be this stuff on top and there's going to be something else on bottom. I'll talk about it. So 12C3 times 10C2. Okay, so that's the probability, or that's the outcomes that we just found from letter A, right? How many ways can 3 girls and 2 boys be chosen? Out of what's the total number of ways that, if it didn't matter if it was boys or girls, it could be either one, what's the total? Well, the total is also a combination, and that's going to be, we want to choose 22 choose 5. Okay, so we know the answer to the top. We just found that, right? 9,900. 9,900. Now what's the bottom? Okay, well, the bottom is going to be 22 factorial divided by 5 factorial times 22 minus 5 factorial. Okay, so when we figure that out, we'll have the probability. Okay, so let's see, let's just work on this right here, right here. Okay, so that's 22 factorial. I'm not going to get rid of the equal sign there. Over 5 factorial. And then 22 minus 5 is 17 factorial. Okay. Okay, so that trick that we used earlier, 22 minus 17 is going to be 22 times 21 times 20 times 19 times 18. Okay, and then on bottom we have 5 times 4 times 3 times 2 times 1. Okay, so let's start dividing. 5 goes into 24 times. Let's see. 3 goes into 21 7 times. 2 goes into 18 9 times. And let's see, 4 and 4 cancel right here. Okay, so that's going to leave us 22 times 7 times 19 times 9. Okay, so let's see, let's pull out the calculator on that one. That is 22 times 7 times 19 times 9, 26,334. Okay, so now we have the top and the bottom. The top is this, and the bottom is this. So 9,900 divided by 26,334 equals, I think that will reduce to 50 over 133. And if you type that in your calculator, it should give you 0.376. Okay. Okay, let's take a look at the next one. It says, let's see, how many possible committees of 5 have no boys? Okay, the number of possible committees that have no boys. All right, to do this, we're going to first say that we're choosing zero boys out of 10. Okay, and then for the girls, we are choosing, that would be 5 out of 12. Okay, sorry, that is a 10. Let me rewrite that. Okay. All right, so the first one will be 10 factorial over 0 factorial times 10 minus 10, or 10 minus 0, excuse me, 10 minus 0 factorial, okay, for that one. And then on this one, we're going to have 12 factorial divided by 5 factorial times 12 minus 5 factorial. Okay, so this one will end up being, remember, 0 factorial is 1, so that one's going to go away. 10 minus 0 is 10, so we'll have 10 factorial divided by 10 factorial, and just like any two of the same number that are being divided, that's just going to turn into, the whole thing's going to turn into 1. Okay, so the first one's 1. I shouldn't write it like that. First one's 1. And then the second one, we have 12 factorial divided by 5 factorial times 7 factorial. Okay, which if we look at the 7 into the 12 factorial, that'll leave a 12, 11, 10, 9, 8 on top. And that gets rid of that. And then we have 5 times 4 times 3 times 2 times 1. Okay, let's clean this up a little bit. 4 and 2 go into 8 evenly. 3 goes into 9 3 times. 5 goes into 10 twice. So that leaves 12 times 11 times 2 times 3. Okay, so 12 times 11 times 2 times 3, 792. Okay, so 1 times 792 is 792. Okay, and the last one, what is the probability of the event that a committee of 5 chosen at random consists of all girls? So just like last time, we've got part of our answer already. We've got the 792, which will be our top number, our numerator. We just need to figure out what the bottom is. Okay, so for the bottom, we'll have 792 on top, and this is D. 792 on top, which is what we just found. And on bottom, we are going to have, let's see, it will be it will be this. Okay, so that's 792 over, let's see, 22 factorial, and then 5 factorial, and then 22 minus 5 factorial. Okay, again, I'm going to need to figure out this because I already know the top. I just need to figure out that bottom there. Okay, so remember 22 minus 5 is 17. Times 17 with 5 factorial times 17 factorial. Okay, and we can cancel out that, and the top will be left with, let's see, 792 divided by 22 times 21 times 20 times 19 times 18, and then underneath that we'll have 5 times 4 times 3 times 2 times 1. 792 is still at the very top. Okay, so let's see, 5 and 4 make 20, so I'll cancel those two out. 2 and 3 make 6, which goes into 18 3 times. Okay, and the 1 doesn't matter. So 792 over, and I need to multiply that. See, 22 times 21 times 19 times 3. 26,334, which will reduce to 4 over 133, which will be approximately 0.03. Okay, so about 3% chance. And that's it. I hope this helped you guys come to a better understanding of the counting techniques in probability.